Good morning, Algebra 2. How's it going? So here we are after some wonderful time off, ready to jump back into it real quickly right before the end of the semester. And this is going to be our last target for the semester. And then after this, we'll just start getting ready for that final exam and going over a bunch of the other topics from earlier in the semester. So the last thing that we're going to cover is going to be 5.3, which is graphing a quadratic equation. Now, we already know the quadratic equation is going to be a parabola, that U-shaped graph. And so we're really looking at two different forms of equations that we're going to be graphing, that vertex form and then standard form, which we've looked at both of those for solving quadratics on the last target, 5.2. Now, to graph the quadratic equation, there's only three steps we have to do. The main part that's going to take the most work is identifying these critical points, I'm calling them. They're basically key parts of the graph that once we plot these points, it's going to be really easy to draw in that U shape, that graph. So once you identify them or calculate these points, then you plot the points, and then the last thing that we do is just going to be draw that curve of that parabola U shape. All right. Here are generally the 5 critical points that we're going to be finding. We won't always have to do this. We don't always have to find these 5 critical points. The main ones that we need are going to be the axis of symmetry and the vertex. And so make sure we know what those are. The axis of symmetry, that's this imaginary line, usually we draw it as a dashed line, that cuts the parabola in half. So if I've got my U-shaped parabola right there, the axis of symmetry would be this, pretend that's a dashed line that goes right through the middle of the parabola. All right, it's kind of like a mirror. The vertex is the turning point of the parabola. Basically, that is the lowest or the highest point of the parabola. All right, so those are the key things that we're going to have on every single parabola. They go together because the vertex is always on the axis of symmetry. And so those are going to be the first 2 things that we find. It's kind of like the starting point of our parabola. Now, the next thing, and this isn't on every parabola, but most of them are going to be the zeros. Now, the zero is another fancy word for those. Well, that is the fancy word. It's just the x-intercepts. They're also called the roots or the solutions of the quadratic equation. And these are just the x-intercepts. So where does my parabola cross the x-axis? So you could say, oh, well, across the x-axis right there and right there. Typically, we're going to have 2 zeros, or roots as they're called. But we could also have just one of them, or we could have 0. So we won't always have any zeros or x-intercepts. The y-intercept, all right, that is always going to be on every single parabola, is the only point on the y-axis, but we won't always see it. Like for my little example doodle graph up here, this is going to keep on going to the left, right? The left. And eventually it will hit the y-axis, but I can't always see it on my graph because I'm not always going to be graphing right next to the y-axis. But eventually that left curve will cross the y-axis at some point. And again, it won't always be there on like the window of the graph, the coordinate plane that we're looking at, but it does exist every time. And then the last thing we're calling a mirror point, or MP for mirror point. Basically, once I have a y-intercept, so for example, if here's my graph, and I know that there's a vertex here, there's an intercept there, and there, the x-intercepts, and then I've got a y-intercept right there. If we think about that axis of symmetry being this mirror line, then I know that if the y-intercept is in this upper left, then there's got to be a reflection point over here, or a mirror point. So when I draw on my parabola, this is a very narrow one, it's going to hit there, it's going to be perfectly reflected over. So I call that the mirror point. It's the reflection of the y-intercept over the axis of symmetry. So these are just the 5 general critical points that we're going to be calculating. Again, when we want you to graph these, you don't always need to use these 5 points. These 5 points won't always exist on every graph, but they're a great starting point. So to get us used to at least this terminology and what these different points represent on the graph, we're going to just look at a graph already and then just try to point out, hey, what is the vertex? What is the mirror point here? All right, so you have a nice drawn out illustration. Go ahead and sketch this graph real quick in your notebook. And all I want you to do is identify these points. Now, this is kind of working backwards from the intended learning target. What we're going to be doing is first calculating these critical points, then plotting them to get the graph. In this situation, I've given you the graph, and we're going to just identify these points, just kind of in a way to help you relate the two concepts together. First is the axis of symmetry, AOS for short, axis of symmetry. That's just this imaginary dashed line that cuts right through the middle of the parabola. And so basically just draw the line that's right in the middle. I'm sure you all can identify lines of symmetry. And the way that we write this is an equation. It's going to be always x equals, because it's a vertical line. So remember, a vertical line has the equation x equals, and then the number is whichever point on the x-axis that the line crosses. And we can see right there that this axis of symmetry is at the point where x equals a -2. So that's the axis of symmetry. And going along with that one is the vertex. The vertex is always on the axis of symmetry. It's the highest or the lowest point on our parabola. In this case, it's that lowest point right down there at the bottom. And so you're simply writing the coordinates, because this is a point, so it's got an x and a y value. The x coordinate is always going to be the exact same number as the axis of symmetry, right? -2, -2. And then the y coordinate, well, you just kind of look, where's this vertically? And that's down 1 from the x-axis. So that coordinate is -2, -1. So that's the vertex. Next up, the zeros, or the x-intercepts of the graph. To identify these, you're just simply looking, hey, where does my parabola cross the x-axis, or the horizontal axis? And again, you can just visualize this right from the graph. You see that it's going to cross the x-axis at 2 places, at -3 and -1. And you can either write this as 2 ordered pairs. This is the more formal way, right? It's the points 3, 0 and -1, 0. And so you can write those out formally like that, but also if you just want to save yourself some time, I'm fine with you just saying, hey, these x-intercepts are the points where x equals a -3 and a -1. That's totally fine with me. All right, I'm not going to worry too much about how you're representing those. I can clearly see, hey, you know what those x-intercepts are. You know where they are in the graph. Y-intercept, that's simply the point where our parabola crosses the y-axis, or the vertical axis. Again, we can visualize this right on the graph there. And I can write this as an ordered pair. That's the point 0, 3. So that's the more proper, more formal way to write it. But again, I'm okay with you just simply saying, oh yeah, that y-intercept is at 3, or when y equals 3. That's going to be our y-intercept. And the last thing that kind of goes along with the y-intercept is the mirror point. And so to identify the mirror point, what we're going to do is start with the y-intercept, which is right up here at the point 0, 3. And basically, you're going to count how far away that point is from the axis of symmetry. So I'm just kind of counting 1, 2 jumps, right? That's 2 points away from the axis of symmetry. Its mirror point has to be that same distance, but in the opposite direction. So from that same axis of symmetry, I'm going to count 1, 2 points, and this is where its mirror point would be, its reflection point. And so this one, I am going to write this as an ordered pair. That is at -4, 3. So these are all of the 5 critical points that we're starting with, but they aren't the only points on the graph, but they are going to be the key ones that we're going to focus on for today. Now, I mentioned this earlier in the lesson that we're going to have to first calculate these critical points. and we're going to calculate them from two different forms. We can calculate these from either when the equation's written in vertex form, which is this right here. That's the one that we were working with on the first target, or standard form, which is the form we're working with on the second learning target of this unit, right? And so I've got them kind of matched up. Vertex form is in blue on the left, standard form is in red. Over here, that's standard form, ax squared plus bx plus c. We use that form when we are factoring, or when we use the quadratic equation. And based on which form that you're given, you're going to calculate the 5 critical points in these different ways. So I've got this nice little table for you. I suggest pausing the video and copying this down in your notebook. We're going to be referencing it throughout the lesson, and on your homework, you're going to need to be able to identify these different pieces and just the different ways you calculate them. The axis of symmetry in vertex form, it's x equals, that's always the way that you write it, x equals, because it's a line. In vertex form, it's easy, that's just h, right? It's whatever you're adding or subtracting. But in standard form, you have to do this little calculation, negative b over 2a. So you take whatever b is, you flip the sign, and you divide it by 2 times whatever a is. That's that leading coefficient. The vertex, in vertex form, well, that's in the name, right? Vertex form, you're given the vertex. You use h and k, and that's it. But in standard form, we already know x. So you know x. Basically, you take that x value from this formula, that's negative b over 2a, and you just plug it in to that equation where the x's are. And so, for example, if we found the axis of symmetry was the number 3, I'd plug a 3 in and write this as a times 3 squared plus b times 3 plus c. And so you're just plugging it into the equation to get the y value, because the vertex is going to be an ordered pair, x comma y. We already know the x because we got that in the previous step. That is the axis of symmetry. Then to get the y, well, you just plug the x value into the equation to get the y. Now the next two, the zeros, remember this is also known as the x-intercepts or the roots. Both of them, if you look, it's pretty similar. It's the exact same thing regardless of the form that you're in. And this is the same for not just quadratic equations, but for any equation. To find an x-intercept of any function, you just make the y a 0 and solve for x. Likewise, to find the y-intercept on any type of a function, not just a quadratic, but any type of equation you have, simply make the x equal to 0, right? So you replace all the x's with the number 0, and then you solve it for y. And that's going to give you the y-intercept. And then lastly, these mirror points. Well, I'm not going to have you calculate those because we're using this to help graph. And so basically just take any point like the y-intercept and just reflect it over the axis of symmetry. So I won't have you calculating that. You're just going to be able to see it from the graph. All right. So let's practice identifying these different points and in each of the two different forms of equations. All right. So I've got the equation y equals negative 2 times x minus 1 squared plus 8. And we need to identify all the critical points. So first off, which form is this in? Hopefully you can all recognize that this is in vertex form. So from that little table on the previous slide, we're using all those equations or formulas in the middle column. First, the axis of symmetry comes from just the x-coordinate of the vertex. You basically just take the number that's being added or subtracted from the x. So you just say x equals positive 1. So you do flip the sign, like we always do whenever you've got a number in parentheses with the x. So that's the axis of symmetry, x equals 1. The vertex, h and k, that's 1, 8. Again, that's just pulled right from the equation, h and k. There's no new techniques here or anything. You're just simply rewriting the number down. You all can do this. Okay, the next thing is the zeros, or the x-intercepts. This is going to take a little bit of calculation. So to find the x-intercepts, we set the y equal to 0. So I'm going to simply replace the y with the number 0. So you have 0 equals negative 2 times x minus 1 squared plus 8. So I replace the y with a 0 because everywhere on the x-axis, the y has a value of 0. And I'm just going to solve this for x. Let's start by subtracting 8 from both sides. So you get negative 8 equals negative 2 times x minus 1 squared. Then we need to divide both sides by negative 2, because that's in front of the parentheses, which means it's being multiplied. When we divide that, we get a 4 equals x minus 1 squared. Now from here, I need to get that x by itself, but it's underneath, or it's in parentheses that are being squared. And so to cancel out a square, we use a square root, which we have to do to both sides. And be very careful here. Remember that whenever you're solving an equation by using a square root, we need to take two options into consideration. So this square root of 4 could equal a 2, or it could equal a negative 2. So we usually write plus or minus 2, because both of those numbers squared would equal a 4. So this x minus 1 could equal a positive 2, or the x minus 1 could equal a negative 2. We have to take both scenarios into account. And again, that's going to give us our two answers for the x-intercepts, as we typically have two intercepts for parabolas. Last, I'm going to add 1 to both the 2 and the negative 2. So if I add 1 to a positive 2, we see that x equals 3. But if I add 1 to a negative 2, we get a negative 1. So those are our two values, our two zeros. So x can equal a 3 or a negative 1. And those are our two x-intercepts for the parabola. Remember that U-shape, it crosses the x-axis twice. Okay, next we've got the y-intercept. Now this is going to be pretty similar. To find the y-intercept, we make the x a 0. So right there, that x, I'm just going to replace it with a 0, and we're going to solve it for the y. So we keep the y in the equation this time. We're figuring out, hey, what would y equal when the x is a 0? Negative 2, parentheses, 0 minus 1. So that's the key step right there to find the y-intercept. You make the x a 0. And we're just doing some basic simplifying here. So negative 2 times, so this is 0 in the parentheses. 0 minus 1 is negative 1. And negative 1 squared is a positive 1. So y equals negative 2 plus 8, which means y equals 6. So the y-intercept is at 6 on the y-axis. So those are the 4 critical points that we can calculate. For that mirror point, we're going to want to go over to the graph. So let's plot these 4 points to help us get started. First off, the axis of symmetry is at x equals 1. So you go to 1 on the x-axis and you draw this vertical dashed line. So that's the middle of our parabola. I know it's going to be kind of split by this left and right. Vertex is at 1, 8. So I go right 1 and up 1, 2, 3, 4, 5, 6, 7, 8. So that's the vertex of the parabola. The zeros, or the x-intercepts, are at 3 and negative 1. So on the x-axis, I go to 3, 1, 2, 3, put a dot. I go to negative 1, put a dot. Those 2 points should always be the same distance away from the axis of symmetry, right, because it splits them down the middle. And then the fourth thing we're going to plot is that y-intercept at 6. So on the y-axis, go up 1, 2, 3, 4, 5, 6, and put a dot. Now for that mirror point, all we do is take that point and you just count, okay, how far away is it from the axis of symmetry? Oh, it's just 1 point. I'm going to go 1 point again in the other direction, and that is where this mirror point is going to be, because it's got to be reflected over the axis of symmetry. And the coordinates of that mirror point would be 2, 6. Now, since our job is to graph it, technically you don't need to write the coordinates 2, 6 down. All I'm going to want you to do is to graph this parabola. So you can start from the vertex and, curve down, curve down. Make sure you've got arrows at the end of this to show that it is a parabola that goes on forever. All right, so that is graphing a quadratic equation from vertex form. How about this one? Well, the equation looks a little bit different. There's an x squared and an x term, meaning we are now in standard form. So from that table with all those like little mini equations on critical points, this is going to be the third column over. Standard form. So the axis of symmetry is going to be calculated by a little mini formula. X equals negative b over 2 times a. Okay, well, a, b, and c, I identify. A is in front of the x squared. That's just a 1. B is in front of the x, so that's this 4. And c, well, I don't need c, but hey, there it is anyways. It's a 3. And so x equals negative b over 2a. Well, b is a 4, so I'm going to write this as negative 4 over 2 times a, and a was a 1. So this is negative 4 over 2 times 1, and which is just a 2. So negative 4 divided by 2 is negative 2. So then the axis of symmetry is at the point x equals negative 2. Now the vertex, I already know the x-coordinate of my vertex is going to come right from that axis of symmetry. That's why we have you calculate that first. And then to get the y value, well, I'm simply going to plug negative 2 in for x there and there. So I'm plugging the negative 2 into both those spots to get the y value. So y equals negative 2 squared plus 4 times negative 2 plus 3. So we're just solving this for y, so just doing PEMDAS on the right. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 3. So y equals 4 minus 8, that's negative 4 plus 3 gives you a negative 1. So the vertex is at negative 2, negative 1. All right, how about the zeros? Well, the zeros of the graph we get by setting the y equal to 0. So we'd say 0 equals x squared plus 4x plus 3. Now we need to solve for the x's, and there's an x squared and an x term, meaning we can't just use basic cancellation and basic algebra to cancel these everything else out, because I can't group the x squared and the x together. But this is where learning target 5.2 is going to come into play. That target was how to solve a quadratic equation, and that's exactly what the situation is that we have right here. We need to solve this quadratic equation for x. Luckily, you've got 3 techniques. We can solve it by factoring, we can solve it by completing the square, or we can solve it with the quadratic formula. Ooh, that one's scary. The easiest option is always going to be factoring, but you won't always be able to, right? Not every quadratic equation can be factored. In this case, this one can easily be factored. You simply look at b and c, and you're asking yourself, hey, which 2 numbers multiply to 3 and add to 4? Well, the only 2 numbers that multiply to 3 are 1 and 3. And so we'd write this as x plus 1 and x plus 3. And then using the zero product property, we know if I'm multiplying 2 different factors and the result is a 0, then one of those 2 factors has to be a 0. And so our final solution, essentially you just flip the signs of the two numbers, right? So what number could I plug in for x that when I add 1, I get 0? Well, that'd be a -1. And over here, this would be a -3. Again, you're just kind of flipping the signs of those two factors. This should be a refresher from the previous learning target. So the zeros, or the x-intercepts, are when x equals -1 and -3. All right, now how about the y-intercept? This one is actually super duper easy in standard form. So remember, to find the y-intercept, you make the x's a 0. So we'd write this equation out, y equals 0 squared plus 4 times 0 plus 3. Well, in standard form, each term is stands alone. And so the x squared term, if you put a 0 in for x, that whole thing is going to be a 0, and it doesn't even matter. It becomes nothing. That middle term, b times x, well, again, if x is a 0, it doesn't matter what b is, that also becomes a 0. It's nothing. And here's why this is so easy. Your y-intercept in standard form will always be c, because you make all the x's as zeros. The only thing you're left with is that constant. So here the y-intercept is when y equals 3. All right, so the last thing is that mirror point, which we're not going to calculate. We're just going to basically look at the graph to help us draw that fifth point. Here we go. Starting off with the axis of symmetry at -2. So on the x-axis, I'm going to go left 2 units and put a dot or put a dash there. And we're going to draw in this vertical dashed line to represent that middle point, that mirror line. This is what the whole parabola is going to be split equally over. The vertex is at -2, -1, which is right down here. Notice that that point is directly on the axis of symmetry, just like it should be. The zeros are those x-intercepts. So on the x-axis, go to -3 and -1. Of course, those are both split by that axis of symmetry because it's like a mirror. And then we have the y-intercept of 3. So on the y-axis, go up to the point 3. And then we can see that that point is 2 spots away from the axis of symmetry. So continue on 2 more times to get to that next one and put a dot for that mirror point. And now you've got enough information to draw in your parabola. So just bring that curve in, up one way, the other way, and draw your arrows. And again, you don't need to identify the mirror point, but if you wanted to, you could say that that's at -4, 3. But our goal is to graph the parabola, and we've got it graphed already without knowing what that exact coordinate is of the mirror point, but it does have a point. All right, let's get some more practice in. Graph the parabola. Okay, so this is in standard form. So first, start with the axis of symmetry. X equals -b, but since b is a -4, a -4 would be a +4 over 2 times a. But a is a 2, so 2 times 2 is 4. So that gives us 1. So we can start by graphing this axis of symmetry at 1. Now, to get the vertex, I'm just going to plug that number into our function, right? It says f of x, but this is the same thing as y equals, it's just a fancier way of writing it, equals 2 times 1 squared minus 4 times 1 plus 4. So 1 squared is 1, and 2 times 1 is 2, minus 4 plus 4, and that's just going to equal 2. So my vertex is at 1, 2. Okay? Next are the zeros, or the x-intercepts. So if I set this equal to 0, 0 equals 2x squared minus 4x plus 4. So I replace the y with a 0. I'm going to solve this for x. Now I can't really factor it nicely whenever there's something in front of the x squared term, but luckily, if you look at every single term in this, everything is divisible by 2. So I'm going to go ahead and divide everything by 2, including the 0, and 0 divided by 2 is still 0, to make this x squared minus 2x plus 2. Now, can we factor it? Well, are there two numbers that multiply to 2 and add to a negative 2? Well, actually, no, there aren't. So this function is actually not factorable. We can't factor it. So what do? Well, we could try completing the square and or use the quadratic formula to try to find these additional points. And or we can just use like a basic t-chart or something like that, you know, where you just take a different random value and plug it in. So sometimes when this happens, if you're just trying to graph it and you don't get a nice factored form, what you can do is think about, okay, if this is my parabola right here, I know that there's going to be a point, you know, somewhere on this line to the right or somewhere on this line to the left, right? If I just go right one or left one unit, there's going to be another point somewhere. So let's try to figure one of those other points out. So all I'm going to do is think, okay, so this is when x was equal to 1. This point here would be when x is equal to 0. And that's actually the y-intercept when I make the x 0. So let's just plug in a 0 for x and see if we can get another point, because we couldn't find those x-intercepts too easily. So let's move on to the next thing, which is the y-intercept. And if you recall, the y-intercept is always just the constant, because if I make this term is 0 and that x is 0, they just cancel out and I'm left with just a 4. So I know that I'm going to have a point at 0, 1, 2, 3, 4. All right, so I've got another point on my graph. And don't forget, along with that y-intercept, the y-intercept was at the point 0, 4, is I've got my mirror point, right? If I reflect that over the axis of symmetry, I get another point right there at 2, 4. Now, if you look at this parabola right now, which way is it opening? Upwards or downwards? Well, if this is the vertex, it's going to be going up like that and up like this. And that's going to continue on forever in that direction. So remember when we tried to find the x-intercepts, that function couldn't be factored? Well, this is why. Is this parabola ever going to cross the x-axis? No, it's not. There are no x-intercepts this time. And so then what do? Well, we still want to try to get some more points, because I've got a rough idea of it, but let's get one more. So I've got a point at the vertex and one point to the right and one point to the left. Let's get another point just by moving one more spot over. So like, how about here? When x is a -1, there's got to be a point somewhere, you know, on this line up here. So let's try to figure that out. Now to do that, nice and easy, we're just going to plug in that new x value into our function. So I'm going to plug a -1 in for x. So the y value will be 2 times -1 squared minus 4 times -1 plus 4. So again, you're allowed to do this. You're allowed to just take any x number and plug it in for x and get a y that goes with it. And that's going to be a point on our graph, on our parabola. All right, so this is just going to be 2 plus 4 plus 4. Add those all up, and we get 10. So then at -1, when x was a -1, y was a +10. So on my graph, if I went to plot that -1, +10, that's all the way up there at the top. And again, because of that axis of symmetry, I can reflect that point over, and I know that there's another point right there. So this actually is our parabola. All right, so that's an example when you don't have any x-intercepts. So we can't always rely on those 5 critical points. But again, all we need to do is just move on to the next point, see if there's a y-intercept on our graph. And if not, then just start at the vertex and just, move one spot over. Well, where's this point? If that doesn't happen, then go to this point, then go to this point. They're always going to exist. They have to have points near the vertex. So start at the vertex, move one to the right or one to the left, and you'll get your other points on your graph to help you graph that parabola. All right, let's graph one in vertex form. So first off, the axis of symmetry is going to be when x equals 1. I'm getting that right there from h. So at positive 1, right, you just flip the sign. We draw this vertical dashed line. The vertex itself is at the point 1, 2, which comes from h and k. So 1, 2, that's our vertex. So I know that that is the highest point or the lowest point on our graph. Now from here, let's get some more points. Let's try to find those x-intercepts, which we calculate x-intercepts by making the y a 0. So we'd write 0 equals -2 times x minus 1 squared plus 2. And just solve this for x. I'm just going to start canceling stuff out. I'm going to subtract 4 from both sides first. Then I'm going to divide by -2 because that's out in front of the parentheses. I want to get rid of that. That brings us to a positive 2 equals x minus 1 squared. And now we need to square root both sides, but I have this square root of 2 now. And then we're going to get a plus or minus, but root 2 isn't a nice number. So we're not going to get, I guess, good x-intercepts on this one that are going to be rational numbers. And so we're not going to be able to figure this one out the way, just like that last one. We have to do something else. So luckily, we're pretty good at just plugging in different x values. So let's go back to our graph. And I know the vertex is this point here when x was 1. Well, let's find the point one spot to the left when x is a 0. All right, and this is going to be our y-intercept as it turns out, right? To find the y-intercept, we simply make the x into a 0. And let's see what we get. So this is -2 times, well, -1 squared is a positive 1. And this is -2 plus 2, which equals 0. All right, so the y-intercept is at 0. Whoops. So we plot it there. And then we know its mirror point is going to be right over here. And then we need to get an additional point. Right, we want to get at least 5 points on our graph. So we already used the point when x equals 1. We have a point when x equals 2. How about a point when x equals 3? So just kind of keep on moving away from the vertex. All right, so if x is 3, let's see what we get. Y equals -2 times 3 minus 1 squared plus 2. Well, that's -2 times 2 squared plus 2. So that's -2 times 4. That gives us -8 plus 2, which is -6. So when x was 3, y was -6. So that's another point on our graph that we can plot. So I'm going to go to 3 and then down 1, 2, 3, 4, 5, 6, put a dot. And then to get our 5th point, we can just reflect that over the axis of symmetry. 1, 2, 1, 2, and that's going to be right over here. And now we have enough points for our parabola. Go ahead and draw that curve in. Doesn't have to be beautiful or perfect, just close enough. All right. So that's in our vertex form. Last one. All right, graph the parabola. So same thing. This is in vertex form. So I already know the axis of symmetry is at +5, right? I flip the sign in the middle. So I'm going to go right 1, 2, 3, 4, 5 and draw this vertical line of symmetry. The vertex is going to be at 5, -6. So from there, write 5 down, 1, 2, 3, 4, 5, 6. All right, so that's the first two things we need to plot this. Let's see if we can find some x-intercepts, right? So we set y equal to 0, and we solve for x. And you can go do this through this process again. If not, if you can't find those, then you can always, like if they don't work out, you can always just go back to your vertex, right? And I've got a point at 5. Well, see if there's a point, when x equals 4, or then when x equals 3 or 2, or when x equals 6 or 7 or 8. So you're just plugging in those different values for x to get the y value that goes with it. So if you want to save yourself some time, you can just do that. So let's go ahead and, you've got enough examples of me solving for x intercepts. Let's do one where you just plug in another number. How about right here? This is when x equals 4. So let's plug in a 4 for x and see what we get. Y equals 3 times 4 minus 5 squared minus 6. All right, so that's 3 times -1 squared minus 6. So that's just 3 times +1 minus 6. And 3 minus 6 equals -3. Okay, so that's another point on our graph. When x was 4, the y value was a -3. So that's a point on our graph, on our parabola, that we can plot. So go to 4, comma, -1, 2, 3, and put a dot. Cool thing with this is once you find one point, just reflect it over the axis of symmetry to get another point, right? Every point besides the vertex has its own mirror point. Now what? Well, we've got 3 points. We want to get at least 5. So let's do that same thing. Let's just take one more point. So how about somewhere on this line? This is when x equals 3. Let's try to figure this out. So when x is 3, what does y equal? All right, so x is now a 3, so I've got 3 minus 5 squared minus 6. And 3 minus 5 is -2. And -2 squared is 4. 3 times 4 is 12. Subtract those, and you get 6. So then, when x was a 3, y was 6. So go to the point 3, comma, 1, 2, 3, 4, 5, 6. And of course, we've got a mirror point that goes along with it right over there. And our points do look like they can connect to form one single smooth but skinny parabola. And there you go. So that is graphing these quadratic equations in vertex form. Now, to practice this on your delta math, these first 4 skills are for identifying things like the axis of symmetry. And to do this, it's just like that first example on my lesson today. Using the graph, determine the equation of the axis of symmetry. So basically find the vertex and just, what is this middle line right here? And you can see, oh, that's when x equals 1. So since it's an axis of symmetry, the answer type is one equation because there's only one axis of symmetry. And you have to write it as an equation. So make sure you put that x equals. If you just put a 1, then you're gonna get it wrong. So you have to type x equals 1 to get the equation. And there you can see that nice dotted line of the axis of symmetry. So that's for identifying the axis of symmetry, the vertex, x-intercepts, and y-intercepts, you're just literally pulling them off the graph. So, hey, do you know what a y-intercept is? Well, yeah, it's where the graph crosses the y-axis. That's right here at 0, 8. And there's only one of them, so I'm going to choose, that's 1 point, not an equation, but it's a point. And so look, you have to type it in as coordinates, 0, 8. And there you can see it's highlighted there in yellow. That's the y-intercept. Now the last one, this is where it's going to really get fun, the graphing the parabola. And so you're going to plot it on here, and you do need to plot at least 5 points. That's why on all my examples, I made sure we graphed at least 5 points, even if they weren't those 5 critical points that we started with. And it does say you must include the roots. Those are the x-intercepts and the vertex. So as always, we should start with the vertex. And so if you think about that, negative b over 2a, because this is in standard form. So negative b, that would be a positive 2 over 2 times a, which is a negative 1. And so you have 2 over negative 1, which is a negative 2. And so this is the axis symmetry. If you plug in a negative 2 for x, you're going to get negative 4 plus 4, which is 0, plus 3. Is that right? I don't remember. So anyways, you plot the points, and once you get 5 points, then it will automatically put in your parabola. And you see how the line perfectly goes through each of these? That's how you kind of know that you made a valid parabola. If I didn't, if I put a point like over here, see how it's not hitting each of these points exactly? So that's a good indicator to let you know, hey, yeah, I'm doing something wrong. Maybe I need to fix this point. And there you see it hits all 5 points. And again, you just have to make sure that you include the roots and the vertex. So the roots for this one, oops. Well, I just kind of made these up right now. So you would have to make sure that you've got the points on the x-axis somewhere, and then however else the graph goes, and submit that. The last thing, this one, graphing parabolas level 3. This one's even trickier because it won't always fit on the graph. So this first thing you do is change the scale. You're graphing those constraints. And so before you start to graph it, once you calculate, like, hey, where's the vertex? Because the vertex might not be on this part of the coordinate plane, you know, between negative 10 and 10. So you might need to change this. So if I make the x scale a 3, and, you know, the y scale a 3, then you see how every line now goes up by 3s, 3, 6, 9, 12, 15, and so forth, so I can plot more points. So if I need to get to the point 15, 12, well, I can graph that. Now I can plot that, okay? So it's just one extra step of scaling it, and then plot the roots, the vertex, and 2 other points. So you've got those 5 points that you need to graph as well. And this is just an optional exercise on your homework to get you some practice, because on your test you are just going to get a blank graph and you're going to have to graph it. But if you don't get it, don't worry, it's not going to count against you for this homework assignment, just this level 3. You do have to do all the others. All right, so good luck on this. Have fun, and great job making it through this semester. I will talk to you all later. Have a great day.